Okay, these Unit 13 notes here, we're going to talk specifically about exterior angles of polygons. Okay, and just as a reminder, exterior angles are formed by an extended side and the side adjacent or next to it. Okay, so if I, for instance, let me try to draw a pentagon. Doesn't have to be a regular pentagon. Okay, but here if I take this side and I extend this side and then use this adjacent side, the exterior angle is going to be that angle that's on the outside of the polygon formed by that extension and that adjacent side, okay? Exterior angles are always a linear pair with that interior angle here. Okay, so for instance, let's get these. If I let this angle, this interior angle be A and this exterior angle be B, whatever A plus B was has to be 180 degrees because linear pairs are supplementary. All right. Now, when we talked about the sum of interior angles, that was always dependent upon the number of sides that the polygon had. But with any polygon, regardless of the number of sides, the sum of the exterior angles is always 360 degrees. Okay, it does not matter if it has 3 sides or 5 sides or 12 sides or 47 sides. When we add all of the exterior angles up, we will always get 360 degrees. Okay. If we want the measure of one exterior angle of a regular polygon, though, if the sum is 360, to find the measure of just one of those exterior angles, we are going to divide by the number of sides. So a regular pentagon, has 5 sides. So we're going to take 360 divided by 5. And that means that each exterior angle of a regular pentagon is 72 degrees. A nonagon has 9 sides. So we are going to take 360s, that sum, divided by 9 congruent exterior angles. And each of those exterior angles then is 40 degrees. And a dodecagon has 12 sides. So we're going to take 360 divided by 12 for a measure of 30 degrees for each exterior angle. Okay. Now down here, these 3 examples. Again, remember, it does not matter how many sides the polygon has. Each of these exterior angles, when we add all of them up, we will get 360 degrees. All right, when I'm doing these, I like to start with a variable. So I'm going to start with y. The sum means to add. So y plus 40 plus 65 plus 60 plus 70 is going to be 360 degrees. All right. Now, since I only have one expression with y, I don't have to change my y. Don't have any more y's that I need to add. But when I add 40 and 65 and 60 and 70, I get 235 degrees. Okay, so I've already used with these 4 angles, I've already used 235 degrees. I need to find out how many degrees are left for angle y. So 360 minus 235 is 125 degrees. So y is 125. Okay, that's your final answer. This next one is a quadrilateral, but again, it doesn't matter how many sides. So I'm just going to add all of my angles together. So one of them is x minus 11. Another is x plus 10. Another is 31 degrees. And then we've got 2x minus 42. Okay. Here, I do need to combine my like terms. So I've got 1, 2, 3, 4 x's total. All right. A negative 11 plus 10 plus 31 minus 42. Okay, all of these numbers here, those constants, we're going to combine. Gives me a negative 12 or a minus 12. But again, that sum still equals 360. Add 12 to both sides. And then 372 divided by 4 tells me that x is 93 for this second example. Okay, last but not least, I've got 1, 2, 3, 4, 5, 6, 7. This is a heptagon, but that doesn't matter. We're just going to add all of these exterior angles together. Okay, so I'm going to go ahead and combine like terms as I'm going through this. So I've got 1, 2, 3, 4x. And then I see 21 plus 42 plus 29 plus 14 minus 10 and minus 20. For a total of a positive 76. If I subtract 76 from both sides, 360 minus 76 gets me 284 on my right side. I still have 4x on my left, so I need to divide both sides by 4 to get an x value of 71.